Welcome to Cooper Beeline Cable Ladder Training, Lesson 1, Cable Ladder Basics. In this lesson, we will cover some of the basics of Cooper Beeline's cable ladder, including the materials and finishes offered, as well as describing cable ladder applications. There are 5 key takeaways that we'll be covering in this lesson: materials and applications, cable ladder construction, fitting construction, standard splicing, and specialty splicing. By the end of this lesson, you should be able to understand types of cable ladder materials and its applications, identify types and methods of cable ladder construction, understand construction of fittings, and differentiate between standard and specialty splicing. You should expect to complete this lesson in approximately 45 minutes. Cable ladder, also known as cable tray in the United States, is used to support cables used for power distribution and communication. They are often used in commercial or industrial construction as an alternative to open wiring or electrical conduit systems. Cooper Beeline offers steel, aluminum, and fiberglass cable ladder options that can be used for varying applications. Cooper Beeline also offers these materials in a variety of finishes to suit the environment in which the ladder is installed. Cable ladder is used in both commercial and industrial applications and in several different markets. Oil and gas markets, example 1. Oil and gas markets, example 2. Oil and gas markets, example 3. Manufacturing facilities, example 1. Manufacturing facilities, example 2. Manufacturing facilities, example 3. Commercial buildings, example 1. Commercial buildings, example 2. We will begin by taking a look at the indoor and outdoor applications, along with the corrosive and non-corrosive materials. Cooper Beeline offers a steel cable ladder with a hot dip galvanized after fabrication finish. This process involves completely immersing the cable ladder fabricated steel product into a bath of molten zinc. This results in a metallic bond with a zinc coating that completely coats all surfaces, including edges and welds. Hot dip galvanized steel cable ladders are ideal for applications in an indoor or outdoor non-saline environment. Hot dip galvanized steel can handle a maximum temperature of 260 degrees Celsius or 500 degrees Fahrenheit, and a minimum of -29 degrees Celsius or -20 degrees Fahrenheit. Salt spray tests of hot dip galvanized steel conclude that it should not be used for saline environments. As a rule, the thicker the coating of hot dip galvanized zinc on a cable ladder, the longer the lifespan of the ladder. Here is a comparison of ounces of zinc per square foot of surface coating on the cable ladder versus the service life in years. Note that coating thickness is linear to lifespan. Thicker coating is equal to longer lifespan, and Cooper Beeline ladder is coated to ASTM 123 with 1.5 ounce per square foot per side. The service life is defined as the time to 5% rusting of the steel surface. Cooper Beeline coats its hot dip galvanized cable ladder with 1.5 ounce thickness per square foot. This chart indicates that with this coating thickness in a rural environment, the service life of Cooper Beeline cable ladder is about 40 years. Comparatively, the chart also indicates that this same ladder in a heavy industrial environment would not be ideal, with a service life of only 10 years. Cooper Beeline stainless steel cable ladders are fabricated from continuous roll-formed American Iron and Steel Institute, AISI Type 304, or AISI Type 316 or 316L stainless steel. Stainless steel is the best solution in extreme conditions such as corrosion resistance, appearance, and locations where product contamination is undesirable. Stainless steel can handle a maximum temperature of 426 degrees Celsius or 800 degrees Fahrenheit and a minimum of -184 degrees Celsius or -300 degrees Fahrenheit. Salt spray tests show that even after 1,032 hours of exposure, the stainless steel has little, if any, corrosion. As a result, both the 304 and 316 types are acceptable for any environment. Cooper B-line aluminum cable ladders have a high strength-to-weight ratio, making them easier to install and capable of carrying heavier loads than steel cable ladder. On average, an aluminum ladder weighs 60% as much as the steel equivalent. Aluminum may experience some chloride pitting in a marine environment, but it does not affect the structural integrity of the system. When aluminum surfaces are exposed to the atmosphere, they immediately form a thin oxide film to protect the metal from further oxidation. Cooper B-line manufactures cable ladder made of aluminum alloy 6063-T6. This is a copper-free alloy that is ideal in chemical or marine environments. Aluminum cable ladders are also optimal for equipment grounding conductors, EGC. They are adequate for circuits with ground fault protection up to 2,000 amperes. Cooper B-line offers 3 different types of fiberglass ladder. We offer a gray color fire-retardant polyester B-line F series that has good corrosion resistance in most environments. B-line also offers a beige color fire-retardant vinyl ester B-line FV series, which is for more severe environments and has a higher heat distortion temperature. The third type of fiberglass we offer is a black color fire-retardant zero halogen Distat B-line FA series. This dissipates static charge, smoke generation, and toxicity for mass transit requirements and offshore applications. Distat cable ladder is still a non-conductive system and cannot be used as an equipment ground conductor. However, the product's slightly conductive surface veil allows it to dissipate small static charges to an earth ground. Conforms to ASTM D257-99. Fiberglass cable ladder is acceptable for any environment because of its properties. UV, 3 levels of protection. 10 mm veil of polyester or vinyl ester. UV inhibitors in the matrix. UV inhibitors in the pigment. Fire resistance. Conforms to ASTM E84 Class 1 and UL94 VO. Self-extinguishing when fire source is eliminated. Sealing after cutting. Does not need to be sealed. Over time, fiberglass takes the properties of the environment, negating benefits of sealing. Reference: Code of Standard Practice. Let's recap what we have covered in this section on materials and applications. Steel, ASTM A1011, ASTM A1008. Advantages: finish options, call out ASTM number, structural grade steel, and lower thermal expansion contraction. Service: indoor, pre-galvanized, outdoor, HDG. Aluminum 6063-T6. Advantages: copper-free, marine grade, easier field modification and installation, excellent strength-to-weight ratio, and excellent grounding conductor. Service: indoor, outdoor. Stainless steel ASTM A240. Advantages: excellent corrosion resistance, withstands temperature extremes, and 316, good choice for acids, chlorines. Service: indoor, outdoor. Fiberglass. Advantages: excellent corrosion resistance, lowest thermal expansion contraction, and lower weight than steel and stainless steel. Service: indoor, outdoor. In this section, we will learn about steel cable ladder construction. Cooper Beeline offers two steel cable ladder solutions, a Nema series solid side rail and an IEC series slotted side rail. The solid side rail is the standard used in North America. It is tested to Nema standards and specified with imperial units. Imperial units are units in inches, feet, pounds, etc. Nema series solid side rail is manufactured in North America, the Middle East, and Korea. The maximum length of the Nema series steel side rail is 24 feet. The IEC series slotted side rail is tested to IEC standards and is in metric units. It is manufactured in the UK, Korea, and Malaysia, and the maximum length is 6 meters. Cooper Beeline's unique side rails are made of an I-beam design construction. The I shape allows for lighter ladders and easier installation while providing more strength. Cooper Beeline's side rails. Enlarged top flange allows stiffness. I-beam design provides best strength-to-weight ratio. Bottom surface has additional support for rungs. To illustrate the value in the I-beam profile, we'll see the variance between the C-shaped side rail and an I-beam side rail profile. The side rails are similar in height and gauge, but the I-beam profile is much stronger. C-section side rail profile. Sample characteristics: 6 inches high by 16 gauge side rail, 86 pounds per foot on a 12 feet span. I-beam side rail profile. Sample characteristics: 6 inches high by 16 gauge side rail, 208 pounds per foot on a 12 feet span. The rungs on both Cooper Beeline's Nema series and IEC series cable ladder are welded by certified welders. The construction is a multiple point welding system which provides multiple points of connections. The rungs are welded to the side wall and the bottom of the I-beam side rail. This provides a secure connection and adds strength to the overall cable ladder design. Cooper Beeline IEC series cable ladder rungs are constructed with a flanged bottom, which adds strength, like the strut-shaped rung. These rungs can be alternating in orientation to allow cables to affix to the top or bottom of the rungs easily, or even have them all face one direction, for example, upward or downward. The rungs also have slots along its length for easy attachment of accessories, including M10 hardware that is available to attach a cable cleat directly to the cable ladder. Nema series cable ladder rungs provide system integrity and are an integral part of the ladder. The rungs of a cable ladder system represent 40% of the entire cable ladder system. Rung A is the standard rung used for widths of 24 inches or less, 600 millimeters. Rung B is standard for widths greater than 24 inches, 600 millimeters. Both rungs are able to support over a 200-pound, 91 kilogram, of concentrated load, over and above the rated cable load. Now let's discuss the aluminum cable ladder construction. Cooper Beeline aluminum cable ladder is a Nema series solid extruded side rail. It is tested to Nema standards and is available in multiple lengths, heights, and widths. All dimensions are in imperial units. It is manufactured in North America, the Middle East, and Malaysia. Cooper Beeline's largest aluminum cable ladder offering is the S8A series. This is an 8-inch high side rail available in 12 to 36-inch widths and can be manufactured in 40-foot sections with a load rating of 101 pounds per foot. Cooper Beeline's I-beam side rail is designed for maximum strength-to-weight ratio. Additional material is added to the top flange to increase the cable ladder stiffness. The weld bead provides positive rung lock and added material to disperse the heat. The bottom inside flange provides rung support. The bottom outside flange allows space for hold-down clamps and expansion guides. The upper flange outside is for securing the ladder cover and conduit to ladder adapters. I-beam side rail, best strength to weight. Added material for increased stiffness. Weld bead. Positive support for rung. Easy attachment for hold-down clamps. Easy attachment for cover or conduit clamps. The rungs of the cable ladder represent 40% of the entire cable ladder system. Rung A is the standard rung used for widths of 24 inches, 600 millimeters, or less. Rung B is standard for widths greater than 24 inches, 600 millimeters. Both rungs are able to support over a 200-pound, 91-kilogram concentrated load over and above the rated cable load. In this section, we'll look at the steel and aluminum cable ladder fittings construction. Let's start with the steel fittings, which have a C-shaped profile and end tangents. Cooper B-line fittings are constructed of a C-shaped side rail, which allow for a smooth, non-mitered radius for maximum cable bend radius protection. The fittings are also manufactured with Nema Series 3-inch or IEC Series 100 mm end tangents that allow the splice plate to be flush against the straight section and fitting when connected. This helps increase the overall strength of the system. The aluminum fittings have the I-beam side rail shape for added strength. End tangents allow the splice plate to be flush against both the straight section and the fitting when they are connected, increasing the contact surface area and the strength of the overall system. Here are some illustrations to demonstrate the importance of tangents on each end of the fitting. No tangent. The issue with the perfect circle is that it doesn't allow for maximum splice contact. The splice would have to be curved for this connection. 3-inch or 100 mm tangent. This maximizes splice contact surface area, which increases the strength of the overall system. This section will cover standard splicing of cable ladders. Cooper B-line offers unique wedge lock splice plates. This allows the splice plate to be held in place by the cable ladder, so the installer can easily attach the hardware without having to hold up the splice plate. With the splice plate snapped in place and minimal hardware, being on a ladder installing the splice plates is safer and easier. Aluminum wedge lock splice plate is structurally integral. Increases SX of side rail. Is self-supporting and has faster, easier, and safer installation. There is one pair included with each ladder section. When deflection becomes a concern, Cooper B-line has a solution with their mid-span splice plate. The mid-span splice plates allow for random splice location. The wraparound design supports the side rail on the bottom of the ladder sections. Expansion joints are common in long-run outdoor applications, where temperature variations result in thermal expansion and contraction of the cable ladder system. Cooper B-line's heavy-duty expansion splice plates are engineered to eliminate an additional support at each expansion joint, where cable ladder systems are utilized. This allows installers to support an expansion joint without additional supports. Cooper B-line offers a wide selection of accessories including covers, barrier strips, beam clamps, supports, and more. Cooper B-line's full breadth of products can be viewed at our website, www.cooperbeeline.com. Trapeze Support Kit. Bonding Jumper. Divider. Grounding clamp. Covers. Cover clamps. Cable ladder clamps. In summary, Cooper B-line cable ladder is designed to last. Side rails include I-beam side rail that allows for less material to be used while maximizing the strength. Enlarged top flange for stiffness. Bend-in sidewall that locks in rungs and provides material for a strong weld. Bottom surface supports rungs, and support for a 200-pound concentrated load beyond cataloged cable load. Welds include multiple point welding of the rungs, ensuring the rung is secured to the side rail. Rungs have stronger rungs on wider trays. Strut rungs available as an option. Support over a 200-pound, 91-kilogram concentrated load over and above the rated cable load. Splice plates. Aluminum wedge lock splice plates have a design that allows the weight to rest on the snap-in splice and not on the hardware. Fittings have 3-inch or 100mm tangents to provide full splice contact. You have come to the end of Lesson 1, Cable Ladder Basics, Steel, Aluminum, and Non-Metallic Cable Ladder Offering. Let's review what we have covered in this lesson. You should now be able to understand types of cable ladder materials and its applications. Identify types and methods of cable ladder constructions. Explain construction fittings. And differentiate between standard and specialty splicing.